Hello, everyone. My name is Tebogo, and I am a software engineer at BBD. I'm currently at VFS at Vodacom Financial Services. And today we are going to tackle one of the most common sources of bugs and pain in software development, null exceptions, and yeah. So these issues, most of the time, they lead to unpredictable behavior. I don't know why it's not changing. Unpredictable behavior, crashes, and hard to debug code. It's not changing, right? But what if there was a way that we can write our code without nulls and exceptions? Functional programming offers exactly that. An approach where nulls are replaced by something safer and exceptions are turned into something explicit and manageable outcomes. We'll explore how these techniques can be applied, and it's only right if we do so using a programming language like F#. But these principles, of course, can be applied in any other languages like your C#, your JavaScript. So this is Tony Hoare, the inventor of the null reference. In his talk back in 2009, he basically apologized for inventing null. He called it his $1 billion mistake because of the amount of errors it has caused worldwide and is still causing even now. Nulls are problematic because they represent an absence of a value, but they don't really tell you why the value is absent. They introduce uncertainty. Anytime a variable or a function can return null, you have to ask yourself, is this value safe to use? You might dereference a null pointer and you will see fireworks in your code. Exceptions are not also that much better. Although they signal errors, but they can be thrown anywhere in your code, meaning it will be hard for you to trace the root cause. Worse, they can be silently caught and ignored, leading to hidden and mysterious bugs in your code. So what's the solution? We can rethink how we represent optional values and errors. Functional programming introduces powerful abstractions like the option and the result that eliminate the need for nulls and exceptions. These types forces us to explicitly handle both the success and the error part, ensuring that no path is left unexplored. In functional programming, we avoid null references by using the option type. This type either holds a value, which is some, or none, which is the absence of a value, instead of just throwing null and hoping for the best. Here's how it might look like in practice. In this example, we have this try-find method. This try-find method returns option, meaning we know that the result might be null. So you are forced as a programmer to actually handle both cases where you do have a value or you don't have the value. So we see this is how we can handle some null references in F#, but what about in other languages? There is an alternative mechanism I'm sure many of you guys know about. It's the optional chaining. In optional chaining, um, it's a safe way for you to check for, or no, it's a safe way for you to access nested properties without explicitly checking for null and references. In this example here, we have the address. In this example here, if a user or the address is null, the expression returns null. So this short circuits it. So if any of these two are null, then the whole expression is null. While this is convenient, I mean, it's a one-line code. It doesn't require you to explicitly think about handling the nulls in between at each step here. In F# land, option type forces you to deal with both the presence and the absence explicitly. So instead of just throwing null, you can like actually cater for the possibility of absence. While this is more verbose than C#, which is just like one line, this forces you to be explicit in your code, leading to fewer bugs and less edge cases. While option type handles the presence and the absence of a value, they don't give us much information about why something went wrong. This is where the result type comes in. This type captures both the successful and the errors, allowing you to handle your errors in a more structured way. Okay. In this example, Instead of throwing an exception while trying to divide by 0, we just return an error with a descriptive message. This approach makes error handling explicit, predictable, and much easier to manage. One of the biggest advantages of using return types is that they compose beautiful. In functional programming, you can chain operations together and the errors will propagate naturally throughout the whole chain. Here's an example of how this might work, where we have our safe divide being used inside the add then divide. So if there's any errors, they will be propagated. And then at the end, you can choose to handle your errors, where if everything went right, you can just print out the result. Or if there is any errors, you can take further actions with that. So in real world application, these techniques lead to more reliable and maintainable systems. By eliminating nulls and using structured error handling, you can drastically reduce the number of bugs in your code. So this leads to increased confidence in your code because makes your debugging much more faster and more robust. Also, companies like Microsoft and Twitter, now it's X, they killed the bed, and also Facebook, they have adopted these strategies in part of their systems. They've seen these benefits. So you too can also do this in your code. So really, in conclusion, we have seen how functional programming can help us avoid pitfalls like nulls and exceptions by using the option and the result type. So wrapping it up, I encourage you to guys to explore these techniques further and see how you can also improve your code, making it more explicit and robust. So thank you for your attention.